work, the main parts and why we use them. Vacuum on non-condensables such as water from a system. We need to remove these with a vacuum pump because they cause the refrigeration system to operate inefficiently and they can also corrode the internal parts. This procedure is carried out before a new system is charged with refrigerant or when an existing system has undergone some repairs where the refrigerant has already been recovered. In either case, there's a chance that air and moisture has contaminated the inside of the system. On a typical air conditioning system, you'll see the vacuum pump is connected via a manifold across the high and low pressure side of the system. A better way to do this is to remove the manifold completely and connect the vacuum pump to the suction line with a pressure gauge connected to the liquid line. We connect the pressure gauge here because it's the furthest point in the system so you get a true reading. Now I have a motor on the back and the compressor on the front. On the top we have a handle and on the bottom we have a support base. We then have an inlet which connects to the system to remove the air, and then above the compressor section we have the exhaust or the outlet. On the front of the compressor section we find an oil sight level glass so we can tell how much oil is in the chamber as well as its condition. As we take the unit apart we can see that we have a fan and protective casing mounted at the back of the motor. Then inside the motor we have the stator which holds the copper coils, but we're going to look at this part in detail just shortly. Concentric to this we have the rotor and the shaft which drives the compressor. At the front we have the compression chamber. This is the two-stage compression version which allows us to pull a deeper vacuum, so we therefore have two compression chambers. Inside the chambers are the compressor rotors and the vanes which move the air out of the system. On top of the compression chamber is a reed valve which vents the exhaust. When we remove the fan's protective casing, we see that the fan is connected to the shaft which runs through the pump. The fan is used to cool down the electrical motor, and it will blow ambient air over the casing to dissipate this. The fins on the casing increase the surface area of the casing, which allows us to remove more unwanted heat. Inside the motor, we have the stator, which is wound with copper coils. When an electrical current flows through the copper coils, it will generate a magnetic field. The rotor is affected by this magnetic field, and this forces it to rotate.